form that they wanted. So there's different ways of making telescope mirrors. The key to the new ones that they're making nowadays is the fact that they're big, but they're also very light. If these telescope mirrors were made the old-fashioned way, well, the 4 meter we're going to go look at weighs around 33,000 pounds. So like an 8 meter one would, let's just say it would weigh 66,000 pounds. You know, so that's awful heavy. And if you had telescope mirrors that big, it'd be really difficult to build any kind of mounts to actually move those massive mirrors around. So with the advent of these new telescope mirror making methods, we're actually able to have much lighter telescope mirrors, and we can use much smaller, lighter mounts to actually move them around on. They're called what they call alt-azimuth mounts, and as opposed to the equatorial mount that you'll see when we go out and look at the 4 meter. Okay, so that's kind of what's happening with the new telescopes, and it's going to be really interesting and exciting when they get these things open, but unfortunately we do lose a lot of our funding up here from the National Science Foundation because they have putting all their money in these big new fancy telescopes, but that's just the way it is. Yes, sir?
Are there going to be any more new telescopes here?
Up here? Probably not. Nope, they build, all the new telescopes get put down in the Atacama Desert in Chile because they got really high mountains there and the air is really dry. That's another thing astronomers like is really dry air. They don't like a lot of moisture or humidity in the atmosphere because the more moisture and humidity in the atmosphere, the more difficult it is for you to do near-infrared imaging. Now, near-infrared is that portion of the electromagnetic spectrum just barely out of our ability to see on the red end of our sight. You know, we can see green, yellow, green, blue. We can see red, but then there's a little spot in the electromagnetic spectrum just beyond what we can see in the red that's called near-infrared. And we have all sorts of cameras and stuff that can pick that kind of stuff up. Our eyes can't. But so if there's a lot of moisture in the atmosphere, that kind of near-infrared information gets kind of filtered out through the moisture in the sky. Oh yeah, then the other telescopes will always be being put up in Hawaii, 2 up on Mauna Kea. So those are the two primo spots. That and space, but there's not too many going up in space, other than the Herschel. What's that?
There's a James Webb.
Yes, the Webb telescope. That's the next one.
The mirror on that looks like that. Yeah,
that's the LSS 2. Yeah.
How big is the mirror for that one?
For the which one?
James Webb.
That might be around 8 meters, something like that. It's bigger than what's up in the Hubble.
Yeah, Hubble's like a 3.
But that's a whole different kind of telescope.
Yeah.
That's really intended for a lot of infrared imaging and stuff.
Mm-hmm.
Okay, we ready? All right. If you need to get a permit to drive up there, go see if there's anybody up there to talk to. Otherwise, we'll walk up. We'll make a few stops on the way up. So if you're in reasonable shape, you might be able to make it.
Can you use the restroom? So you can use it. You can use it. It just means it's made for everybody.
We just talk to them and try to convince them that they shouldn't. There's regulations and everything that kind of keeps it at bay somewhat. Okay, the wind telescope I talked to you about is this silvery looking one right up here. So that has the 3.5 meter spin cast area. It also has what they refer to as a spin cast. That weighs about 4,000 3.5 meters, whereas the 4 meter telescope we're going to go look at now, the telescope's weight on that thing goes around 33,000 pounds. So you can see that there's a considerable difference. This one was built in 1993.